Okay. The article, Effective Variables Related to Mathematics Achievement Among High-Risk College Freshmen, that was a lot, examines a relationship between attitudes towards mathematics and success at the college level of mathematics. 20 men and 38 women selected at random from those identified as being at high risk of failure because they did not meet the usual admission requirements for the university participated in the study. Each student was asked to respond to a series of questions, and answers were combined to obtain a math anxiety score. For this particular scale, the higher the score, the lower the level of anxiety towards mathematics. I feel like they should have done that opposite because that's just confusing. Summary statistics are given below. So we have our mean and standard deviation for men and women. And our N values, just so that we have them here and don't have to go back through and read. We had 20 men and 38 women. So I'm just going to add those there so I don't have to go read through to find the numbers written in words. Does this data provide evidence that, as many researchers have hypothesized, the mean anxiety score for women is different than that for men? Test an appropriate hypothesis and state your conclusion. So our null hypothesis, mu sub w minus mu sub m is equal to 0. Now it says is different than, so what does that make our alternate? Not equal to, so mu sub w minus mu sub m is not equal to 0. Let's look this up. All right, so our conditions that we're checking, I'm trying to remember what they all are. Independent, to go back and find where I have them all written down so I can, random, yes, 10% condition, yeah, I mean, obviously 20 men and 38 women isn't necessarily a huge number, but it's enough. Nearly normal, the total number is greater than 40, so we should assume that it's fine. It doesn't specify, but I think we're good. So conditions met. And so we can do a 2-sample t-test on this to find that. Now, we don't know what our degrees of freedom is, again, because we have that issue of it being 2. So we can use the 2-sample t-test. It's really hard to say. 2-sample t-test. For I guess women first, so 36.6, then 12.3, 38, then for men 35.9, 11.9, and 20. And then it's the not equal one, and then it is not pooled. Do not pool. And if it asks, obviously we have stats in this one. I don't remember if this asks for that or not. I can never remember which one asks and which one doesn't, so.
Is it going to tell us, like, in the problem if we pool it or not?
Yeah, I don't think any of them actually get pooled in this book. But yes, it would say that. Like, I don't even think I've seen one in the AP book that has pooled.
This is data.
Stats.
Data would be from the list.
Okay.
Yeah.
How far out do you want us to go?
I guess let's just go to 3.
0.834.
And our alpha level, it doesn't specify, but what do we assume alpha to be if it doesn't specify?
0.05.
So, what does this tell us then?
We fail to reject the null.
Should say, yeah. My p-value of 0.834 is not less than alpha. So, there is not enough evidence to suggest that the average math anxiety score differs between men and women. When y'all put that in your calculator, did it give you the t-star value for this problem?
I got a T value, is that what?
Yeah.
Then, yeah.
What was it?
0.210.
And did it tell you what the degrees of freedom were?
Yes. 39. It's just all rounding up, so 39.
Okay, that's fine. Probably a good thing, even if you use the calculator function on the exam to write that stuff down, give kind of everything that it gave you off your calculator, so that it knows, they know what you got and all that fun stuff. And I could have put in here the fail to reject thing as well. As long as you have, because it was asking specifically if there was evidence that, so that's kind of why I just left it out. But if you had it, that would be fine too. Just make a note here. Okay, you might as well go ahead and put those 2 sets of numbers into a list in your calculator because you're going to need it. This is basically the same exact type of problem we just did, except for this one is using data instead. wait, I'll finish typing that in. I'll actually read the problem so we know what's happening. A total of 23 Gossett High School students were admitted to State University. Of those students, 7 were offered athletic scholarships. The school's guidance counselor looked at their composite ACT scores, wondering if State University might admit people with lower scores if they were also athletes. Assuming that this group of students is representative of students throughout the state, what do you think? So, my null hypothesis would be that mu sub, I'm going to use NA for non-athlete and then A for athlete. So mu sub NA minus mu sub A is equal to 0, meaning that they are exactly the same, like the admittance and not. So what would it be for the alternate?
Grade.
Yep, greater than. So mu sub NA minus mu sub A is greater than 0. So how about our conditions? Are these independent groups?
Yeah.
Yes. Is it random?
Some representatives.
Yes, it points that out. Is it what, large enough sample size or whatever?
10%.
Yeah. The paper that I have has this acronym, and I'm trying to figure out what their letters of their acronym mean. So that's why I was like, and then
The,
normal. Yeah. Assuming it's normal, I guess, right? 23. It's in that range, so it should be fine. It's on the I was gonna say it's on the higher end of that range, but I guess realistically it's technically on the lower end, but it's close enough. All right, so conditions are met. So we can proceed with the 2-sample t-test. Now, we do need to be aware that there are only 7 athletes out of this group, which is a very small number. So we just need to keep that in mind when we're going about these problems. So, 2-sample t-test. But this time it's with data, and I don't remember off the top of my head all the other things that get plugged in. So, anyways, just... But it'll ask you for your L1 and L2. I know that, but I just don't remember what order.
And we want like greater than mu2.
Huh?
We want greater than.
Yes, as long as your non-athletes is your L1.
And not pool.
Yes, do not pool. Not pooled. Good question. And again, we don't have a confidence level given to us, so we're going to assume alpha is 0.05. And then once you get all this information, I'm going to have you tell me what T and the degrees of freedom are, but ultimately I'm trying to find the p-value at the moment.
When would we change the frequency? Like when?
I don't think, I honestly don't know. Every problem I've ever done is just one. So I assume, I'm guessing it's something that would be blatantly obvious in this problem statement that would say something about it, but I've never seen one that's not one. I don't really know what it's for. I'm not even going to try to pretend that I know.
The p-value is 0.96.
I got 0.035.
That's what I was expecting to see. Are your numbers in backwards? Because what did you get? 0.96?
Yeah.
That would probably make sense. Is it 0.965?
Yeah.
Yeah, yours is backwards. Did you do your L2 and L1 backwards? I have L1 as non-athletes and L2 as athletes. Okay. Oh, okay. Well, I don't know. Are they in the right order in the 2-sample t-test thing?
Which one goes first?
Should be L1.
Probably next one. That is really later.
Josh, what did you put in?
For what?
Like, what order did you put the stuff in? Because he says he has the exact same thing.
Like in the lists?
No, like
The,
in the
Yeah.
2-sample t-test, how did you put it in?
so there's data, L1, L2, 1, greater than, mu2, no. For the whole thing.
Is this what you have?
Listen.
Okay.
What did you have, Josh?
I pressed less than.
That would make sense.
Yeah, that would make a difference, and that would explain why yours was exactly opposite of his, like 1 minus. All right, so what is this? Oh, well, actually, before we do that, what are our degrees of freedom? What did it produce for you?
Like 10.13.
That's fine. And what was T?
2.02.
So if you wanted to go back and do it by hand, you should get that number when it's all said and done if you did it by hand for T. Just using the formula for T. That was in the notes. All right, so what does this p-value tell us?
It's kind of small.
Is it smaller than alpha?
Smaller than
Yeah.
alpha.
Okay, so what does that mean?
We would like to reject.
Rejecting the null.
So what does that mean about evidence?
So there is enough evidence.
Yep. So my p-value of 0.035 is lower than alpha. So I reject the null hypothesis, meaning there is enough evidence to suggest that schools, or at least that one in particular, admit athletes with a lower ACT score than non-athletes on average. Just gonna write this on the bottom here. Problems, again, you don't need to worry about these until after break unless you just want to get them out of the way. 9, 10, 13, 20, and 36. And because this unit only has 3 chapters, we'll do chapter 25 when we get back, and I'll have the review questions for you as well afterwards. I can't really give them to you now because I actually don't have a paper of them filled out myself. I have the paper made, but I guess for some reason I don't have one of them filled out, so I can't give you that at this point. I could probably go through my pictures and use the search bar and find them, but from where I'd written them like this, but I won't be able to do that in the next little bit, so you'll just get those after. So at the earliest, Friday after break would be part 1. I won't do it before that. So. And we'll just see. I don't know. I mean, chapter 25 is probably about the same. We can probably do it in 2 to 3 days, but I'll give time to review and all that, so. And we also have some tennis matches, so I don't think we'll be leaving out of this class, but we could be. I don't know. TBD.